So today we have another forces and motion question to go through using the SUVAT equations. I've already done a few videos on this topic, the links of which are below in the description for this video. So please go back and watch them if you don't know what the term SUVAT means, if you don't understand how to resolve forces, and so on. Let's take a look at this question. So figure 3.1 shows an aeroplane of mass 3.4 times 10 to the 5 kilograms accelerating uniformly from rest along a runway. After 26 seconds, it reaches a speed of 65 meters per second. Calculate the acceleration of the plane. We list the variables, as I've said before in previous videos: S, U, V, A, and T. You put in the things that you have, and then you put a question mark next to the variable that you want, and then you work out which SUVAT equation you need. Time is 26. The speed is 65, the final speed. The initial speed, well, it tells us it's accelerating from rest, so that's 0. And then the acceleration, well, that's the thing that we want. So there's the question mark. So we need something with V, U, A, and T. The equation we need is V equals U plus AT. So rearranging gives A equals V minus U divided by T. We substitute in the numbers that we have. So it'll be 65 minus 0 divided by the time it takes, which is 26. 65 divided 26 gives us 2.5 meters per second squared. The resultant force on the aeroplane. The equation linking acceleration, mass, and force is F equals ma, where m is the mass of the object, a is the acceleration, and F is the resultant force. And so we can plug in the numbers that we have. The mass of the aeroplane is 3.4 times 10 to the 5. That's a 5, by the way. Multiplied by the acceleration at 2.5. So let's work that out. And that comes to 850,000. And the unit for force is newtons. Just after taking off, the aeroplane continues to acceleration as it gains height. State two forms of energy that increase during this time. Right, so think back to content you might have covered in your GCSE physics course, so grade 10 if you're in the US. What are the energy conversions? What are the different types of energy? So what we need to think about is potential energy, kinetic energy, thermal energy, chemical energy, gravitational potential, elastic potential, those sorts of things. The first obvious one that comes to mind is the plane is accelerating. It's getting faster. So that means the kinetic energy will increase. And then the other energy that would be increasing is the object, in this case, which is the plane, is gaining height. So when you move an object up through a vertical distance, so for example, if you're walking up a stairs or you move a box from the floor onto a table, that object gains gravitational potential energy because you are doing work against gravity. So the other increase is gravitational potential energy. Right, finally, state one form of energy that decreases during this time. So what could possibly be decreasing as this plane is taking off? Well, it's not going to fly by magic. So it's got to use something. So it's going to be burning fuel as it gets faster and faster. So therefore, the type of energy stored within the fuel is chemical energy, which is then being turned into kinetic energy and other energy transfers. It will be losing, or the chemical energy will decrease as more fuel is burnt. I hope that's helpful. If you've had any value from this, please do like and subscribe. And if you need any help, just comment down below and I will get back to you.